All right, hello everybody. So I apologize for the setback there. We were had a couple technical difficulties just trying to get everything set up here. So if you'd like to join in and go over a couple problems from the review packet or any other problems that you may have before your test tomorrow, this review is specifically for BMC and PM115. So the link is written right here at the top. You can use this link to go straight to the Google Slides and post any questions you may have. It's a Q&A format, okay? And I'm just going to give people a couple minutes to sort of join in here and see if we get anybody to tune in, and we will get started in a couple minutes. So I did want to mention that if you go to the bottom of the YouTube page, there is actually the link that I have written here is actually under the description of the YouTube page. Okay, so you can also just go ahead and click on the link if you want to do that instead of typing all of it in. Okay. But again, I'm just going to give people a couple minutes here, and then we will continue to get ready for your test tomorrow. All right, guys. So if you are, it looks like we got maybe one viewer, so thank you for tuning in. Hopefully you'll find this helpful, whoever you are. So I'm going to go ahead and post the link, or really just kind of write it on the screen real quick in case you would like to post any questions. Okay, so let me just get that set up real quick. All right, so here is the link if you would like to actually post questions. So it's goo.gl. /slides /6U6 D8M. All right. So again, if you're just tuning in to the YouTube review session, I haven't had too many people show up, but in case you would still like to post some questions, this is the link that you would use. So it's goo dot, so there is a dot here, GL /slides / and then those series of numbers and letters. So 6U6D8M. Okay. So if you'd like to post questions, you can go in and do that there, and I will see them show up in real time, which is pretty cool. So I'll give you guys a couple seconds if you'd like to go ahead and post something. Okay. So again, just to clarify, we're starting to get a couple viewers here. So if you guys are interested in posting any questions, this is the site to go to. Okay, very quick link. So it's goo dot, so there is a dot there. So goo.gl /slides /6U6D8M. Okay, and if you type questions there, you can do it anonymously. You can put your name, it doesn't matter. I will see your questions as you post them. Okay. So I'll give you guys a second. If there's any specific questions that you would like to ask, and we will get started then. All right, so it looks like we got our first question in. So thank you to that person, whoever posted that. So they said, so the anonymous user said, the domain of a function without the graph. So that's a really great question. So most of the problems that we've done in class, we've asked you guys to just go ahead and graph them, and kind of from that picture we find the domain and range. So let's talk about an example, and I'm actually going to look at the PM115 review, and I'm going to look specifically at topic 7, the families of functions, where it says g of x is equal to log base 4 of x minus 1 plus 2. So again, we could go through the process of graphing this and then get the domain and range very easily, just kind of visually looking at it. But if we want to do it without the graph, this part here, right? So if I'm looking at a logarithm, regardless of what the base is, in this case the base is 4, I know that this piece here has to be greater than 0. So in other words, I can't do log base 4 of 0, right? Oops. So log base 4 of 0, that's undefined. Similarly, I can't do log base 4 of any negative number, right? Those are also undefined. So it strictly has to be greater than 0. So what I usually do here is if I don't want to graph and I want to find the domain, I take the argument or that piece that's inside the logarithm, I set it greater than 0, and then I simply just solve for x. So here I have x is greater than 1. So in interval notation, you would say everything to the right of 1, but not including 1, because there's no or equals to sign under there. Okay, so this would be the domain for g of x. Okay, I will say that the range is a little bit trickier in the sense of there's not really anything that you can sort of plug in, or in this case, like we set the inside equal to greater than 0, and then we just solve for x. The range, you have to really kind of be more familiar with the function. So actually for all logarithms, the range will always be all real numbers. Okay, so that's just something that you kind of want to keep in mind. But that's how you would find the domain of that. Okay. All right, so the next question is from Yvonne. Thanks for tuning in, Yvonne. So he said, can you go over how to find the break even? So that's a great question. So let's take a look at that. Let me clear my page here. All right, so this is a question we went over in BMC. So I'm going to look at topic 6, the modeling with linear functions. So just as a quick review here, you usually are asked to find 3 types of functions, right? It's usually the cost function, the revenue function, the profit function in that order. So this problem said a manufacturer has a monthly fixed cost of $1,000 and a production cost of $60 per unit. So right away I know that my cost function will be 60x, $60 per unit, plus an additional $1,000 regardless of how many units I make, right? The revenue function is going to be based on the fact that each unit sells for $80. And so the profit function is always the revenue function minus the cost function, right? So when you do this, you have to be careful and put everything from the cost function in parentheses, because that minus sign has to distribute, that negative one has to distribute to all of this. So here I have 80x minus 60x minus 1,000 equals 20x minus 1,000, okay? So we've done that a lot, and we found the profit function, but then like Yvonne is asking, how do I find break even, or the break even point? In other words, the number of units x that would help me break even. So first of all, what does break even mean? So break even, you can think of it in two ways. First is when the profit is 0. Okay, so you don't make money, you don't lose money. Or because the profit is equal to revenue minus cost, that's the same thing as saying the revenue minus the cost is 0, right? And an even more condensed version of that is if I add c of x to both sides, I have r of x is equal to c of x. So these are the two guys you want to focus on for breaking even, right? So you want to find either when the profit is 0, like this one, or where the revenue is equal to the cost. In other words, revenue minus cost is 0. Okay, so in this case, what I would do is I would take this equation here, and I would now set it equal to 0. So let's see what that would look like. All right. So I'm just gonna hide this for a second. Whoops. All right. Actually, let's just go up here and we'll go ahead and clear this. So we have 20x minus 1,000, right? So now what I'm going to do is let's take my eraser. Yeah, for some reason it's not letting me erase very well. All right. Well, so we'll just clear this real quick then. So what I want to do is I'm going to take the let's see what happened here. Sorry, Yvonne. So what I want to do is I want to take that function. I'm going to go ahead and set it equal to 0. So let's change the color a little bit here, and we're going to say 20x minus 1,000. That was that profit equation we found. Set it equal to 0. I'm going to add 1,000 on both sides. So I have 20x equals 1,000. Divide by 20. So x would end up being 50 units. So at 50 units, I would neither make money nor lose money. Okay, so hopefully, Yvonne, that helped you out on that one. Okay. All right, thank you for tuning in, Georgia. So Georgia asked, will we be given the parent functions during the final? It's a great question. Unfortunately, you will not be. So you want to be familiar with those. The ones that are kind of most unique that you want to be familiar with are probably the logarithm and the asymptotes, right? The other ones you're kind of probably more familiar with. So we have a couple of them. First, we have let's see, we have x squared, right? So just very quickly, that's like our parabola, right? Then we have value. So if we have that, oops, the absolute value, the way I remember that is absolute value. It starts with a V, right? So that's the one that gives me the V shape. Then we have y equals the log, and just think of any base. They all have the same kind of property, so I'm just going to pick base of 2. Okay. So a logarithm always kind of has this shape like this. Remember that logarithms have a vertical asymptote, right? So this one would have a vertical asymptote at x equals 0. Then we have, let's see, another one would be the other one that kind of is sort of funky looking in terms of it has more than one asymptote actually, right? So that was the one that looks like this. That would be the y equals 1 over x, right, or some variation of that. So you just kind of want to be familiar with the basic parent functions that Georgia is pointing out here, just so you're ready to go for the test tomorrow. Okay. So I know that that doesn't help in terms of learning them, but at least you know, you have a place to start with, and you know, some functions to go back and look at. So, and I believe in the PM115 book, I think this was all on page 111, right? So if you go to page 111, there's a that's where the chart starts with the characteristics of different transformations, and I think either the pages before or after that are where all the parent functions are at. Okay, so you can use those to get you ready for that. Okay. Okay, so I'm just gonna give everybody a couple seconds, see if we maybe get a couple more viewers, or if you guys have any other questions. Okay. So again, thank you for tuning in. Hopefully you guys find this helpful. Just kind of get some last minute answers in before the test, okay, or last minute questions. Okay. And feel free, remember, if you're a little you know, hesitant about posting a question, you can always post it anonymously. You don't have to put your name to it if you don't like. Okay, that's totally fine too. Okay. So while we're waiting for another question to come in, I'm going to go ahead and maybe go over a function question where you are asked to do some transformations. So let's do that. All right. So let's say, let's get red in here. So let's say that they give me, let's say 1x plus 5 minus 2. Right, so this is that one that's going to have the two asymptotes. So first of all, one thing that I immediately know is the vertical asymptote is at x equals -5. The reason for that is because wherever the denominator is 0, in this case, if I evaluate at -5, I substitute -5 for x, I get division by 0, which is not allowed, and that causes a vertical asymptote. And actually, I also know the horizontal asymptote too. It's always the number that's kind of in this format. Okay, so that's just kind of a quick way to get the vertical asymptotes. And I just saw Yvonne posted a question. So just very quickly, if you were to graph this, right, just a very rough sketch. It would look something like this. Right. You can always plug in a couple numbers if you're not sure where to start. So for example, if I plug in, let's say, what would be going? -4. 1 divided by -4 plus 5 is 1 divided by 1, which is 1, and 1 minus 2 is -1. So at -4, I have a point at -1. So I know that the graph is going to go roughly like this. So there's my two branches. Okay. So that's something you can, and then you could go through the whole domain and range thing again. Okay. All right. So Yvonne is asking about topic 5A. So let's take a look at 5A. Okay. Okay. So topic 5A, this is in, let's see. So this is going to be in the BMC packet. So topic 5A is talking about a cell phone plan, and it's a set of inequalities. Okay, so let's go ahead and take a look at this. So let me clear this off first. All right, so topic 5A, you are choosing a new cell phone plan. At Verizon, you can obtain a flat rate of $60 per month, while at Sprint, it is $25 per month for unlimited calling and data and 10 cents per text message. This must be sent to make Sprint a better deal than Verizon. So the key here is that you're interested in text messages. So text messages are going to be your X's, right? That's the thing that's changing. So the setup here that I'm going to do is I'm going to make just kind of two sides here, Verizon and Sprint, okay? And first of all, what does it mean for Sprint to be a better deal? Well, that means that Sprint costs less money. So we'd want to use the less than symbol pointing towards Sprint. And so now all I have to do is set up the inequalities and solve them. So Verizon, you get a flat rate of $60, regardless of how many text messages you send. Whereas Sprint, you get the price of $25 per month for unlimited calling and data, but each text, keyword each, so times, right, is going to cost me 10 cents. So this is going to be my setup here, okay? So that's going to lead into me just having to solve this. So the first step I would do is, let me just change my color, I would subtract 25, right? So I get to, is that 35? And then divide by 0.10. Remember, dividing by 0.10, one way you can think about this, 0.10, that's in the hundredth place, so that's 1 over, or excuse me, the tenth place, there's a 1 in the 10th place, so it's 1 over 10, right? So really what I'm doing here is 35 divided by 1 over 10, which is 35 times 10 over 1, right? To divide by a fraction, you multiply by its reciprocal. So that'd be 350. So what you'd want to say here is, so we'd say x less than 350 text, right? So I kind of ran out of room here, but what you'd want to say is something along the lines in words, since it has a context of that do less than 350 text in order for Sprint to be a better deal, right? In order for it to be cheaper, okay? So that would be your setup there for that one. Okay. All right. So Georgia asks, can you go over a problem similar to topic 7 that asks how you would find the x-intercept of g of x? Okay, so that's a good one to go over. So Georgia is referring to the PM115 review, where they give you a logarithm and they ask for the x-intercept. And actually, in the review itself, I actually didn't ask for what the intercept would be. I just asked how would you find it if you could. The reason I did that is just because this one turned out to be a decimal. So let's see what we get here. All right. So let's clear this. So this was the one we looked at earlier that had this g of x is equal to log base 4 of x minus 1 plus 2. Okay. So what I'm going to do here is I'm just going to kind of tweak this a little bit just so it works out a little bit nicer. And I'm going to erase this. There we go. And I'm going to make this a, what would work here? Minus 4. Okay. So if I want to find an x-intercept, right, an x-intercept always has the form of some number comma 0. That number can also be 0, but it's some number comma 0. In other words, the y value is equal to 0. Well, another way that we write that is g of x, right? So, or f of x or h of x, however you want to say it. So what I'm going to do here is to find the x-intercept, I'm going to set everything equal to 0, right? Now I want to point out this is different than finding the y-intercept. Finding the y-intercept, you would plug in 0 for x, okay? So that's a different thing. And so what we're going to do here is just solve for this. Let me switch my colors. I'm going to add 4. Add 4. 4 is equal to log base 4 of x minus 1. And then I'm going to use a relationship I know about logarithms and exponents. And note that this is really saying 4 to the power of 4 is equal to x minus 1. 4 to the power of 4 is equal to x minus 1. Okay, and so I'm just going to solve for this. So I would add 1 here, add 1. So 4 to the power of 4, what would that be? Let's see. That would be 256. So 256 plus 1 would give me 257. Okay. So what that means is that my x-intercept for this specific problem is going to be 257, comma, 0. Okay. So that's how you would do that setup. That's a comma there. Okay. So again, I set everything equal to 0. I go ahead and rewrite it in exponent form. That's what I did in the red there. And then I'm just solving for x, okay? Okay, so let's see how we're doing on questions here. Okay, and you can do this for anything if you want to do a couple practice problems. The reason that I chose the minus 4 over here, if you're wondering, is because I knew it would work out nice with a power of 4, or excuse me, a base of 4 here. It doesn't have to be the same, but sometimes it makes it a little bit easier. Okay. You can pick smaller numbers too, so that it's not as huge as 257. Okay. So let me give everybody a couple minutes, see if there's anybody else tuning in or if there's any other questions that come about. So while we're waiting for some more questions to pop up, I'm going to go over another problem of logarithms, because that seems to be something that a lot of people really wanted to spend a lot of time on, so that's a good thing to look at. So just a couple things you want to remember about logarithms. So for example, if I say log base of 1, right, and any base here, if I do log base 10, log base 1,000, it doesn't matter, that is always equal to 0, okay, because that's the same thing as saying 4 to the power of 0 is 1, which we know is true. Base 4 have the same base and the same argument in that parentheses there. The answer is always 1, because 4 to the first is always 4, okay, and again, these are just examples. You can do it with any base here, okay. Oops. Okay. And then again, just to review, we already said this earlier in the video, but if you do log base 4 of 0, that's undefined, right? So there's nothing I can raise 4 to get 0, right? So we can't do that. And then similarly, another thing that's undefined is if I do any sort of negative numbers, that is also undefined, right? There's no number that I can raise 4 to get a negative number, okay? So those are just a couple of laws that you want to remember as you're dealing with logarithms. Okay. So let's actually do one other thing with logarithms. So I'm going to do a full-out graphing and transformation problem with logarithms. Okay. So let's say, let me see, what would be a good one? Let's say I say g of x is equal to 2, let's do -2 log base 3 of x minus 1 plus 1. Okay. So let's go through a couple of things here that could be useful. Okay. And Ivan, I'll get to your question in 1 second. So if I have something like this, again, the domain, I could graph it, or I could do the method that we talked about earlier in the video. So if I set x minus 1 greater than 0 and solve, I get x is greater than 1. So my domain is 1 to infinity, not including 1. Okay. And so when I graph this, let me set this up. What I can do is I can use a couple test points as well as some of the things that I know about transformations. So let's just write our transformations down here. Okay, so one of them is going to be a shift right 1 because of this inside 1 here. Minus 1, you always do the opposite of what's there. We're going to have a vertical stretch, okay, and we'll say by a factor of 2. I'm going to have a reflection, so we'll do REFL over x-axis. That's the negative sign up front. And then lastly, that plus 1 all the way in at the end is going to be up 1, or shift up 1 unit. Okay. So I'm going to go ahead and put my vertical asymptote at x equals 1. Okay, that's where that domain comes from that I used, right? And then I'm just going to use some points to help me out here, just to kind of get me some anchor points. Again, you can also use the transformations from the other parent function. So let's say I plug in 2, right? So if I plug in 2, let's kind of walk through here what I would get. So I'd have, if I plug in 2, I'm going to have, if x is 2, I have -2 log base 3 of 2 minus 1 plus 1. So that's -2 log base 3 of 1. So this becomes -2 times log base 3 of 1 is 0. So -2 times 0 is 0, plus 1 is 1, right? So this whole output gives me a 1. So if I plug in 2, just clear this for a second. Let's get my eraser. If I plug in 2, I get out. I have a point here. And there's another point. You usually want to do at least one other point, but just to save some time because I want to get to the other questions, you want to follow the general shape of the logarithm, but in this case it's different because it has a negative, right? It has this over the x-axis. So what actually happens is it kind of goes down like this now, right? Everything is flipped. So you just want to keep that in mind, okay? All right. All right, so Yvonne, you said, could you do a walkthrough of topic 7a in the BMC packet? So that was the system of equations question, okay? And the anonymous user that posted about 5b, I'll get to you in 1 second, so just give me 1 minute to answer this one. So topic 7, it's talking about a local school, and it's going to be a system of equations. So the setup that you want to use here is they tell you that the student tickets are $5 each, and the adult tickets are $10 each. So what you're looking for here is the number of student tickets, or the number of students, and the number of adult tickets, or the number of adults that came, right? So again, they give us this setup that looks like the following. So it's $5 for each, or per student ticket, plus $10 per adult ticket, and the total is equal to 500, right? So this is kind of like our money equation. And then they also tell us that the sum of the adult and student tickets has to add up to 70, okay? So this would be our setup for equations. So you can use substitution or you can use elimination. I'm going to use elimination, okay? So what I'm going to do here is let me get a different color. I'm going to multiply the second row by -5. So -5 times equation 1. Okay. So the reason I'm going to do that is because then I have opposite coefficients in the x values. Now I could have also eliminated the y's, but I chose to do the x values. Okay, you can do any way you'd like. Okay, so you have this set up here, and now I add the two equations. The x's cancel. I get 5y equals 150 divided by 5 divided by 5. So y is 30. Okay, which means that x, if x plus y is 70, x has to be 40. So there are students that went, or 40 student tickets that were sold, and 30 adult tickets or adults that came. Okay, so that would be your setup for that one. And again, you could do substitution, you could do elimination, it doesn't matter. Okay, so another question was from an anonymous user, topic 5. Let's talk about for that. So unfortunately, I'm not sure what class this person is from. If they wouldn't mind, they don't have to post their name, but if you could let me know what exam review guide you're looking at, so I know which 5B you're looking at. Okay, so I'll give them a second to post that. Hopefully they're still there. Okay, so again, if the anonymous user asked about 5B, if you could just clarify for me real quick if that is the BMC or the 115 packet. All right, so BMC. So this was a BMC. Thank you for clarifying that. So BMC, this actually works out real well because this is the second part of the problem that Yvonne was asking about. So let's go back here. So we have y is 30 and x is 40, right? So it says solve the following system of equations by graphing. So I could have actually solved this problem here by graphing. but they tell me to use either substitution or elimination. So for 5b, we have 3x minus y equals 2, and we have negative x minus y equals 6. So there's two ways you could do this. You could either put both of these guys in slope-intercept form, y equals mx plus b, right, and graph them and see where they intersect, because that's really what they're asking about, right? That's what a solution to a system of equation is. Where do the lines intersect? Or you can use the intercepts, which is kind of a quicker way. So let me show you guys kind of a tip to do this a little bit quicker. So if I'm looking at 3x minus y equals 2, if I want to find the x-intercept, well, that means that y is 0. So if I plug in y is 0, the y goes away and I get this. And if I solve for x, I get 2/3. So the x-intercept is at 2/3 comma 0 for this purple line. So 2/3 is a little less than 1, so I'm going to put it, let's say, right there, right? And then if I similarly look for the y-intercept, that means that x is 0. So if I substitute x is 0, I now have negative y equals 2, which means positive y is negative 2, right? Divided by negative 1. So there's a y-intercept at 0, or yeah, 0, negative 2. So this is the purple line, right? And I'm going to make it a little bit straighter if I can. There we go. Okay. And if I go through that same process, let's make the next one green, for negative x minus y equals 6, right? For the x-intercept, if I plug in 0 for y, you will see that you get out negative 6, right? That y, the negative y will go away. I'll have negative x equals 6 divided by negative 1. So I'll get negative 6 as my x-intercept. 1, 2, 3, 4, 5. Add one more. 6, right? And then the y-intercept, if I plug in 0 for x, I actually also get out negative 6. So that is, need another dash there, and then we come down here, 1, 2, 3, 4, 5, 6, right? So those, whoops, sorry about that. So that goes like this, right? So what I'm looking for is this intersection point. Now you can see the graphing is not super clean here, so it's a little bit harder to see that intersection point. So let me just see if I can see what that would be. So I think that would be -1, -5. Yeah. Okay. So that would be your solution there for that one. Okay. Sorry about my screen going in and out of there. I was just messed up for a second. Okay. And so anonymous user, I apologize. I realize. Okay, I don't know how I missed that. Sorry, I was doing a completely different problem. I got thrown off there. So the BMC 5B, sorry about that. So hopefully you still find that as a good review, but 5B. So this was the, okay, the coin one, right? So let's talk about the coin one. So this one is a little bit tricky. So it's talking about coins. It says you have 215 coins total, consisting of nickels, dimes, and quarters. And he has twice as many dimes as nickels, 15 more quarters than dimes. So the key here is that everything is in terms of the number of dimes. So I'm going to make that my variable, and then I'm going to try and define everything else in terms of that. Okay. So let's see what that would look like. So if x is the number of dimes, I know that he has twice as many dimes. So 2 times the number of dimes is equal to the number of nickels, right? Whoops. Right? What that means is that if I want to solve for this, saying that there's twice as many dimes as nickels is saying if I take the number of actually, let me clarify this. Let me make this a little bit easier to see. So the way I wrote it didn't really match what I was trying to say. But if I want to say that there are twice as many dimes as nickels, that means I have to multiply the number of nickels by 2, and that gives me the number of dimes. In other words, if I have X number of dimes, and I divide that by 2, that is equal to the number of nickels. Okay. One way you can think about that is like, even just make up your own problem. If I have, let's say I know there are 4 dimes, right? Then in the context of this, there would be 2 nickels, right? So to get the number of nickels in terms of dimes, I have to cut this in half, and that gives me the number of nickels, okay? So that's one way you can think about that, if that's helpful. So you can draw a little diagram like that. It's always nice to have a visual too, right? And then lastly, there are 15 more quarters than dimes. So if I take the number of dimes and I add 15 to it, that's the number of quarters. Okay, so that's kind of my setup here, and that's going to really be key for finishing the rest of this problem. So now all I have to do is take all of these and add them up to 215, okay? So one thing I could do here is I could multiply both sides by 2 to eliminate that denominator of 2, but it's not too hard to add a half, right? So I have x plus x over 2. I can write this as 2x over 2. I can write this as 2x over 2. So I have 1, 2, 3, 4, 5 x over 2. And then right away I'm going to subtract the 15 over to the other side. So now if I multiply both sides by 2 times 2, finish it up here, I have 5x is equal to 400. So if I divide by 5, x is equal to, what would that be? 80, right? So the number of dimes would be 80, which means the number of nickels would be 80 divided by 2 would be 40. And the number of nickels would be 80 plus 15 would be 95. So these would be your 3 answers here, okay? So there you go for topic 5B. Again, sorry about the confusion earlier, but hopefully that's helpful to you. Okay, so we have time probably to ask maybe one more question if anybody has one. So I'll give everybody maybe a minute to think through, and then we'll go ahead and wrap up if there's no further questions. Again, I want to thank you guys for tuning in. Hopefully you found this helpful. Sorry about getting started a little late. I had some technical difficulties on my end. This is only the second time I've done the live YouTube thing, so still working out some of the kinks. So again, if anybody has any last minute questions. All right, Georgia, so how would you find the domain of problem like number 3 on page 118 in the PM115 book? So give me 1 second. I gotta get my book out and look at that. So just give me 1 second. All right, so I am back. So let's see. So this was page 118, number 3. So I believe this was one of the homework problems. This is a review for us to go over. So this one is, it's asking for the domain, and number 3 specifically says h of x is equal to x plus 5 over x squared minus 36. So first of all, right away you should see that this is something you can factor. This is a difference of squares, so I'm going to do that right away. Okay. So again, where is any restriction in the x values, hence the domain for this function? And what you'll see is that if x is equal to 6 or negative 6, the denominator becomes 0, right? So those are my two restrictions. So my domain, if I put that together, would look something like this. I can either say all real numbers, but don't let x be 6 or negative 6. That's kind of a quick way to do it. Or if I want to do interval notation like we've been doing, it means that negative 6 comes first before 6, right? It's a smaller number. It's on the negative side. So I'm going to do negative infinity to negative 6, not including negative 6, union, negative 6 to 6, union, jump over 6, and go to infinity. So these would be the same thing. So you could do either one of these. Okay, so that would be the domain for that one. Okay, we didn't spend as much time on just kind of figuring out the domain just by looking at a function. That's why I gave it to you guys for homework, just to do some practice. So I'm glad Georgia asked that question. So it's a good review. Okay, just to kind of throw something at you guys. If I looked at, so this was number 3 on page 118. Right. If I look at something like this, number 4, right? It's the exact same thing, except it's a x squared plus 36, right? This can never be 0. The x squared plus 36, excuse me, can never be 0, right? If I try and solve x squared plus 36, oops, x squared plus 36 is equal to 0. If you try and solve for that, you end up taking the square root of a negative number, right? Also, you can notice that this is prime. I can't factor it, right? So the domain would be all real numbers. There is no restriction on x for that one, okay? So hopefully that clarifies it for you guys. Okay, great question. All right, and so with that, I'm going to go ahead and end the live review session. Again, I appreciate you guys turning out. So if you subscribe to the YouTube page, I can try and help you guys out throughout the year even. You can maybe submit some requests for videos or reviews for math courses that you guys take. I've really enjoyed working with you guys. So yeah, subscribe to the page. Let me know what you think. And I will see you guys tomorrow. Make sure you get lots of rest, take a break, and good luck on your test. All right, thanks guys. Thanks for watching. Bye-bye.